Okay, thank you so much. I'm happy that you can hear my voice. So let's wait 1 minute, please. One or other students may join our session, and then we will start this lecture. Yeah, one more student is joining. That's good. Yeah, I think it's better to start. So you see, I welcome you all to this session, to this lecture class, and today we are going to see on fault tree analysis and hazard assessment. Okay, this is chapter 6 for you, the fault tree analysis and hazard assessment. The fault tree analysis, you see, this is a method used to analyze. This is a method used to analyze. See, this is a method used to analyze any defects or accidents, any undesired event that happened in an industry. Okay, so this method looks like an inverted tree. That is why they named it as fault tree analysis. Okay, let me take you to the next slide. With an introduction, you see, in many cases, there are multiple causes for an accident or other loss-making event. Accident, of course, it results in loss to the company, and so many other incidents or events which could result in loss-making to the company. So the fault tree analysis is one analytical technique for tracing the events. Understand? For tracing the events which could be contribute for an accident or other loss-making event. So here you see we are using the fault tree analysis, which is an analytical method, analytical technique. By using this fault tree analysis, we are going to find out, tracing means find out, some events which may end in accident, which may be the reason to bring accidents in a company. Okay, so the fault tree analysis can be used in an accident investigation, and also it can be used in a detailed hazard assessment, just to assess the dangerous situations in a company, hazardous situations. We can use fault tree, and also you can use fault tree analysis for accident investigations. If any accidents have happened, we can do investigations using fault tree analysis method. So the fault tree is a logic diagram. See, the fault tree is a logic diagram. It has a logical order. Okay, that's why we call it as fault tree is a logic diagram based on the principle of multi-causality, which traces all branches of events. You see the name, you can find the word here, branches. Branches means just like a tree has so many branches. This method is also having so many branches of events that could be a reason for the occurrence of an accident. Okay, so branches of events which could contribute to the accident or failure. This fault tree analysis is using some sets of symbols, labels, and identifiers. So when we are using fault tree, we are mainly depending on the symbols, labels, and identifiers. Now I am going to tell you what are the symbols we are using in fault tree analysis. Yeah. So this is the general outline how a fault tree looks like. See, on the top you will have the undesired event. Maybe we can call it as an accident or some loss-making events. Okay, and from them we are coming down. We start at the top. We continue towards downward direction, and we try to see what is before accident, what is this event, and what is before this event. Again, what is before this event? We are just trying to find out the previous event which has been the reason for the present event to occur. Okay, so we start at the top and then we come down in downward directions to find the previous event which is reason for this accident. After finding this previous event, we try to find what is the event previous to this. So like it's a chain of flow. of the events which causes the accident. So this is a general outline how a fault tree looks like. You see, it looks like an inverted tree. It starts from one stem and it having different branches. It is expanding. That's why the name called fault tree analysis logic diagram. And these are the symbols we are going to use when we are following this method. There are so many symbols here, and the mostly frequently used symbols we are going to I will be explaining you in this session. The first symbol is called as AND gate. AND gate means the meaning the output event occurs if all input event occurs. Okay, if this is output direction, there will be an output. If this has the two inputs, if all two input event occurs, then only you will get an output. If any one input event is not there, then you will not get output. That is called AND gate. And what is OR gate? OR gate means output event occurs when any one of the input event occurs. Okay, it is not necessary that all input events should occur. That is the difference between AND gate and OR gate. In AND gate, output event occurs when all input event occurs. But in OR gate, output event occurs if any one of the input event occurs. Okay, you will get an output. That is called OR gate. And the third important symbol we are going to use is XOR gate. In XOR gate, the output event occurs if exactly one input event occurs. Exactly one. You should not have two events or three events. So exactly one event is there, then you will get an output event. Such kind of situations is defined by using the symbol called XOR gate. Okay, and you have one more symbol called as a basic event. That's a circle. The shape of the basic event is a circle. Basic event is a fault or the final event, and a rectangle event, this is simply called as an event. So we are going to use the main symbols: one AND gate, and two OR gate, and third one basic event gate, and fourth one is event. Okay, and so how to approach this fault tree analysis? Fault tree analysis, always it starts from top. You see, a fault tree diagram is drawn from the top down. It starts from top, then it comes down. First point. Second, the starting point is the undesired event. Okay, say for example the first point where the fault tree starts, this is the starting point, and this starting point is the undesired event. Normally accident. Accident is undesired event. Okay, so it starts from the undesired event on the top, and then it moves down. Now you then have to logically work out the immediate contributory fault. What is the next fault before this accident? We have to find it. Okay, conditions leading to that event. Now this may each in turn be caused by other faults and so on. So it keeps going down. The trickiest part of the whole thing is actually getting the sequence of failures. The main thing what you need to note down here is the sequence of failures. You see, I am just showing you. I will just highlight with some colors. Yes. Okay. You see the sequence of failures. This is very important. Which failure is occurring previous to this? So we go in downward direction. Okay. There is a point. Yeah. And so the trickiest part of the whole thing is actually getting the sequence of failure dependencies worked out in the first place. And I'm going to show you an example here. Okay. So how to understand? Let's understand fault tree analysis with a simple example of a workplace getting fire. Let's take this as an example where the workplace is getting fire. So fire is an accident and hazardous as well. So fire can be called as an undesired event. We don't need it. Fire is accident is danger. So fire can be called as an undesired event. So we start this undesired event fire and logically work out. Work out means drawing. Okay, the fault tree diagram. To find the immediate contributory fault conditions leading to fire. Okay. Now I'll just tell you a general knowledge or a common sense. For a fire to occur, normally there should be oxygen always. If there is no oxygen, there will not be fire. And second, there should be some fuel. And third, there should be some spark. Then you will get fire automatically. So that is the reason. You see, I am just explaining you. For fire to occur, there needs to be all of this. There should be a fuel. The fuel may be solid, liquid, gas, anything. And there should be an oxygen, and there should be ignition. So all these three should be there. Then only there is chance of getting fire. Okay. Now, but if you consider the fuel, the next event, but fuel can be either of solid or liquid or gases. Any one. If there is a solid, we can call it as a fuel. If there is a liquid alone, we can call it as a fuel. If there is a gases alone, we can call it as a fuel. So here we are going to use OR gate for fuel. But for fire, we are using AND gate. Understand me? Also, the ignition could be done either by a spark or some other flames or some mistakes. There may be a chance of ignitions. Okay. Now, therefore, we use AND gate for fire to occur and OR gate for fuel and ignition. Oxygen does not have an alternate or combination. So oxygen will be used as is. Now you can see the next one. I am giving you step by step. You see, this is the fire, the undesired event. First event, we should draw this and then come down, select the AND gate, because for fire to happen, we need fuel and we need oxygen and we need ignition. Okay, we need all these things. So AND. So next to fire, draw the AND gate and connect fuel to the AND gate, oxygen to the AND gate, and ignition to the AND gate. Okay, and then let's come down again next to fuel. How we can call there is a fuel? If there is a solid or a liquid or a gaseous. So below the fuel we use the gate called OR gate. Okay, if solid is there, it will ignite. We need not have all the three at a time. Any one is enough to ignite. That is why solid or liquid or gas. Oxygen, no option. It is 100% available. It should be there. It is existing naturally. And if we talk about ignition, ignition may be because of flames, because of spark, or because of some misuse. There may be some flames, ignitions. Okay. So here also we use an OR gate. So OR gate is appearing below fuel and below ignition. Because if any one is there, fuel will exist. Ignition also, if any one is there, ignition will exist. I'll show you this in next diagram. Yeah, in order to prevent the loss, we could first examine the diagram for AND gates. Okay, this is because the loss can be prevented if just one of the condition is prevented. Okay, now if you see the previous diagram, if we want to stop the accident, fire is an accident. If you want to stop the accident, fire, don't focus on OR gate, because if you focus on OR gate, you will try to stop solid, for example, but again there is a liquid. It is a fuel. So you need to stop everything. Okay, to stop the fire, if you concentrate OR gate. But if you concentrate AND gate, it is simple. It is enough if you stop any one, either fuel or oxygen or ignition. If you stop fuel, there will not be fire at all. If you stop ignition, there will not be fire at all. Okay, but stopping oxygen is not possible. So better to concentrate on AND gate, because it is easy to control accidents. Always keep in mind, for fault tree analysis, please focus on AND gate and try to stop any one below AND gate, so the accident can be stopped. Okay, this is what I told here in this slide. Now, analysis of fire triangle, we will try to do with some value. Okay, it's the same model. I am giving some value, how much percentage solid is contributing for the fire, how much percentage liquid is contributing for the fire, how much percentage gases is contributing for the fire. Similarly, how much percentage spark, misuse, flame are contributing for the fire to happen. And how much percentage oxygen is contributing? 100%, because it is available in the atmosphere. So this is the problem. Let me see how to find out what is the cause, how to stop this fire. You see, the fire triangle happens like this. First, fire. The fire happens when the fuel and oxygen and ignition. Fuel happens because of solid, liquid, gas. Solid is 0.1. 0.1 means we have to see the previous value. This is gases. Yeah, it is 10%. So 10% is divided by 100. You will get 0.1. So this is gas. This is the value of the gas. This is 0.02. Maybe the value of solid, gas, solid, and liquid. Yeah. And next is, this is 0.09. This is the value of the liquid. Just divide by 100. Divide these values by 100. So you can convert the percentage into the normal values and you write it here. Gases, solid, and liquid. Oxygen is 100%. So 100 divided by 100 is 1. And ignition, you have 3. Again, it may be because of, you can see the previous slide. Ignition is because of spark, misuse, flames. Okay. So spark is 5%, misuse is 10%, flame is 20%. So here they have given 20%, 0.2. This is a flame, and this is spark, that is 0.05, and this is misuse, 10%, 0.1. So like this you quantify. Quantify means give the values, okay, which is given in the question. This will be the question to you. From the question, you take the values and put it in the fire triangle. And now, after this, you see what happens. We should have a calculation. There are two rules, Majud, rule 1 and rule 2. Okay, I'll just show you with some highlighter. I'm selecting some highlighter for you. Okay, yeah. Yes. So you see there are rule 1 and rule 2. Rule 1 is used for OR gate. Understand? Rule 1 is used for OR gate. Rule 1 is only adding the values. Okay? Rule 1 is only to add the values. You see? Rule 1 is applied to OR gate and it is used to add the values. Rule 2 is used to AND gate, and we have to multiply the values. So I'll just show you how it is done. So the combining probabilities upward to the next level gives the probability of fuel. How much is the probability of fuel? If you see the previous diagram, this is AND gate. So 0.1 plus 0.02 plus 0.09. Just add, because it is all coming under AND OR gate. OR gate means add. Okay. And here also OR gate, add, take the value here. Understand? So 0.1 plus 0.02 is 0.12. 0.12 plus 0.09 is I will just show you in the next slide. I will calculate it. Yeah, this is 0.21. So this 0.21 is the probability of fuel. Write this value in the next fuel. Understand? 0.1, 0.02 plus 0.09 here. Write the value here. Right? And the next is oxygen. We don't have option. Same value comes here, 1. For ignition, again this is OR gate. So add 0.2 plus 0.05 plus 0.1. Add, you will get the value here. 0.2 plus 0.05 plus 0.1 is 0.35. So for accident to happen, fuel is contributing 0.21. That is 21%. Fuel is contributing for a fire, and ignition is contributing 35%. That is the meaning. 0.35 means multiply by 100, you will get 35%. Fine. This is OR gate, so we have added all these three. But if you come up again, we should go up by giving the values. Next one is the fire. We should find what is the probability of fire, or what is the percentage of fire. Percentage of fire, you have AND gate, so you should multiply this value and this value and this value. That is the second rule. Okay, you have to multiply the values below AND gate. you should add the values below OR gate. That is the principle formula, the rules. So now I am going to the next diagram where we multiply. See, 0.21 is the fuel contribution, 1 is the oxygen contribution, and 0.35 is the ignition contribution. So total, if you multiply, you will get 0.0735. That is 7.35% in terms of percentage. Understand? This is the probability of fire to occur in that company based on the given data here. Okay. Now again we have to update the triangle, update the fault tree diagram. So you see, this is 0.21, this is 1, this is 0.35. So here 0.21 multiply 1 multiply 0.35, it is 0.0735. This is the percentage of fire. So from here now we can make a conclusion, you can give a comment. The probability of fire to occur is found to be 7.35%, because we have found here 0.0735. Multiply this value by 100, you will get in percentage, and that value is 7.35%, and that is what we are writing here. Then occurrence of fire could be prevented by preventing any one among fuel, oxygen, ignition. Any one we have to prevent. If preventing oxygen is not advisable, we cannot prevent oxygen because it is existing by nature, it is in atmosphere. So forget oxygen. Then the other two options can be worked out. What are the other two options? One is to prevent fuel. We need to prevent all sources of fuel. Okay. Then to prevent ignition, we need to prevent all sources of ignition. Yes, because it is and OR gate. Now here occurrence of fire could be prevented by preventing either fuel or ignition. Okay. So we can stop any one. If you compare these two values, you see the fuel and ignition can be prevented only by preventing all sources. If you want to prevent fuel, you want to prevent solid fuel, liquid fuel, and gas fuel, all. If you want to stop ignition, you want to stop all. What are they? Flames, spark, and misuse, all. Okay. So among fuel and ignition, the probability of ignition is 35%, more for ignition, whereas that of fuel is only 21%. You can see this from the fault tree diagram. You see, the probability of fuel is only 21%, but the probability of ignition is giving 35%. So ignition is giving more possibility to make accident, fire, okay, compared to fuel. So this is more danger in this problem, because this is having more value, its value is higher than the fuel value. So we will try to stop ignition first. That is safety for us. Okay, that is the comment. So so the probability of fire is more because of ignition than that of fuel. So comparatively more attention is required to control or prevent all sources of ignition. So we focus on to stop ignition first. Okay, that is the conclusion. So that's it. So with this I am concluding this lecture, and these are some question banks. I have given you the similar problem with different values. You can work out yourself. If it is not understandable, you can come to me in my office time and I will explain you. Thank you students for your active participations. If any doubts, you can chat with me now. I will give you 2 minutes time. Or if you wish to meet me in office, you can come to my office. I will explain this again. I will clear you if you have any doubts. Okay? Thank you all for your active participation. If you need any clarification, please come to me in my office time. So with this I am closing this session. Okay, we will meet you soon. We have other means of communications through course message or in my office hours or whatever. Okay, see you. Good night, all of you. Take care. Have a nice weekend.